Hi guys, welcome to Coder Pro. Today we're going to be looking at another LeetCode problem, seems to be a pattern, um, called minimum area rectangle 2. We're given a XY plane with a bunch of points. We need to figure out whether some of these points form a rectangle. And if they do, we need to figure out which one of these rectangles have the minimum area and return the area. Not all points are necessarily have to form a rectangle that is parallel to the xy plane. So let's take a look at the examples and figure out what are the edge cases that we need to resolve for. So in this case, example 1 does not form a rectangle that is parallel to the xy plane. And example 2, we may not use all the points to find the smallest rectangle. Example 3, even though you can see that it forms a parallelogram, it does not form a rectangle, so it cannot be used. Therefore, we return 0 instead of the area of the triangle. In example 4, we finally find a case where there is actually a rectangle that's formed between 0th x-axis to 3rd x-axis, which forms the area of 3, and another rectangle that's formed by area of 2, so we return 2. Let's see how we're going to solve this problem. My initial thoughts are we should use the slope to figure out whether a rectangle exists, and if rectangle exists, we just need to figure out the area, which is simple vector calculation to find the distance between 2 points. And once we find that for parallel and perpendicular vectors, we could just multiply that to get the area. Another property of a rectangle is that each rectangle has 4 sides, 2 of which have to be parallel to each other, and the other 2 have to be perpendicular. So my initial thoughts are we should find the slope, we should store the slope, and we should also find the slopes of points and store the slope. In this case, vectors, because 2 points create a vector, which is the slope, right? Point by itself does not have a slope. So let's go through how we actually do it. We just go through all index in the points, and we go through all the other index in the point, and we find the slope. And let's go through how we find the slope in this case. We find the x diff, the y diff between the 2 points, and it's a simple calculation of finding y diff divided by x diff to find the slope. In this case, I'm using decimal because it's more accurate than using float. And we return decimal. And also, if the x are equal, where in this case you could take a look at, for example, the last example, we have multiple points in the same line, we could run into a case where we divide by 0, which is not ideal. So we return a slope of infinity. Since these points, this slope is hashable, decimal type is a hashable, we can actually store these decimal type directly into dictionaries. Before we store the vector into dictionary, what we need to do is normalize it so we could always query it afterwards. So how I'm doing that is if P1, the first point in the vector is always the smallest x value, and in a case where both x values are equal, we check if the first point is also has the smallest y value. and we store this vector into a dictionary, and we also point the vector itself to the slope that we obtained. In this case, min size, we need to declare a cache for finding the smallest size of a rectangle, and we go to the points that we stored earlier in the cache. And we get the slope and the points, or in this case vectors, resulting in those slopes. If the points, or in this case vectors, let's just change it. Vectors, and I believe that's it. Yep, that's it. Cool. If length of these vectors is less than 2, which means there's only one vector with the exact slope, we cannot form a rectangle because each side, there are two sides in a rectangle that are parallel to each other, and there are two sides in a rectangle that are perpendicular. So we could immediately skip this case. For the perpendicular slope, we need to find out whether they are the inverse slope, right? Because that's how 90 degrees is formed in xy plane. And once we find the inverse slope, we could go through all the vectors that are formed by it, P1 and P2, P3 and P4 in this array. And once we find that, if the P1 and P3 form a perpendicular vector, we could P1 and P3 form a perpendicular vector, and P2 and P4 also form a perpendicular vector. We could say that they are rectangle. And we also have to notice that these P1, P2, P3, and P4 has to be unique points in the xy plane, because otherwise you can't form a rectangle with only 3 coordinates, or 2 coordinates, or 1 coordinate for that matter. So we could skip that case. We also have to normalize the vectors, so we use the dictionary decoy. Just like how we did before, if the x value is greater on P1, we exchange. If they're equal, and we check the y value, so on and so forth. If the m, or in this case slope, happens to be infinite, which means it goes directly from through the x-axis, what we need to do is we actually just need to check whether the y-axis on all 4 points match. Whether the y-axis on P1 exists in either P3 or P4 in the other vector, and whether the y-axis in P2 also exists within P3 and P4. If it doesn't, we could just skip to the next vector. And we also do the same check for whether they cross, whether we're looking at a rectangle when the vector itself crosses the y-axis. At least the slope does. And if it doesn't, then we could skip this case. And for all the other vectors, we need to check whether the vectors that are formed by the opposing vectors P1 and P3, the slope that's formed by opposing vectors P1 and P3, we need to check whether that resolves to inverse slope. In this case, because we're dividing decimal by decimal, it would not be accurate to check whether they're exactly equal. So you can't just check S1, which is case the slope 1 is exactly equal to inverse slope. So in this case, what I'm doing is I'm dividing S1 by inverse slope and minusing by 1, which gives exactly, in a perfect world, it will give 0. If this mathematical function returns anything that's greater than 10 to the negative 6, we could just continue on to the next loop. And we do the same thing with the other 2 points, P2 and P4. And if they all happen to be true, it gets through to this function, where we get the size of the rectangle itself. And then once we get the size of the rectangle, we just check if it's less than minimum size and reset it. And let's go take a look at how we get the size of the rectangle with 4 points. We don't actually need the 4 points. We just need to check whether 3 points, right? We need the parallel and the perpendicular part. In this case, we don't know which one is the perpendicular, which causes the perpendicular vector exactly, because there are 4 points and one of them can be hypotenuse. So, but what we know is the one that forms rectangular will be the minimum distance because it's a 90 degree, right? And that is directly due to Pythagoras theorem. So we find the distance between P2 and P1, and we also find that's the parallel, in this case, that's the parallel distance, and we find the perpendicular between this vector, P2, P1 and P2 with P3 and P4, and that's the perpendicular distance. But one of these will be more minimum, whereas the other one will be larger because it's hypotenuse. And we just need to find the minimum one and then multiply them to each other, which will result in the area of the rectangle. Once we know the area of the rectangle, as I said before, we just have to set min size to it. And once we know that if the min size happens to be infinite, we could just return 0, as the example 3 shows. And if we actually have a min size, we could return that as is. Let's run through the example test case. And looks like it worked as expected. 2, 1, 0, 2, 2, 1, 0, 2. That's what we expect from here. Let's run it. And it worked as expected. Well, thanks for watching, guys. Please leave a like and a subscribe if you like the content. And if you want to see more videos where I solve LeetCode problems, please check out my YouTube channel, Coder Pro. Thanks for watching. Have a good one.